For everybody coming for the first workshop.
Okay, here, I think recording's starting now.
Okay.
Yeah, okay, yeah, I guess we can get started. Yeah, so hey everyone, thanks for coming either online or in person here, but we just want to welcome everyone to the first workshop of the semester. So yeah, this workshop's Blockchain 101, and we can move on to the next slide.
So it's by me and Paul, who are co-dev of this club.
Yeah, so as Perry said, I'm Paul. I'm in my final year of comp sci and the co-VP of dev here, and yeah, joined with Perry here is the same. So for today's workshop, we're going to focus on basically the bare fundamentals of blockchain. So what a blockchain is, how to understand it, how to conceptualize it, and just get like a real high level understanding of how this technology really works. So that being said, most of this workshop is going to involve a number of interactive demos to kind of help everyone understand how a blockchain actually works, which is going to be really nice given the demos. Right. So we're going to have a link to the demo, which to the demo website, I mean, that we're using. So I encourage everyone either who's joined with us now or if you're watching later to kind of follow along and explore it and just kind of mess around with it on your own time. So we have come up with a bit of an agenda on what we're going to cover for this workshop. So I'll just run through that right now. First off, we're going to start off with the question, why are we here? So a loaded question, no doubt, but we're going to give a brief history on blockchain and money, as well as kind of the motivation for this technology. After that, we're going to start breaking down the concept of blockchain in a series of topics. So we're going to do this chunk by chunk so everyone can hopefully have a good base understanding of it. And that's going to take us from hashing all the way to the blockchain topics.
Yep. And then we'll finish. Yeah, go for it.
After that, we're going to build on this foundation of blockchain to understand how it works in a peer-to-peer network using a distributed blockchain. So that being said, I will pass it to Perry and we can get started with the first topic here.
Sounds good. So as from the previous slide, we're going to start with why we're here. So most of you guys are probably curious what blockchain is, but I'll just start with the brief history of the Byzantine general problem, which just describes that the difficulty of decentralized parties on arriving on consensus. So it's like a really ancient problem where there's always there's always a centralized party. And then pretty much it's a game theory problem. That's what decentralized is trying to solve. In the history of money, why Bitcoin exists. It started in 2008 after the financial crisis, because they realized when there's central authority, there's always room for corruption. So what is money? Gold standard is, it was when Nixon in 1970s realized that fiat money is just what our currency is, are not backed by gold anymore. And I'll explain what the drawbacks of that is. So yeah, so as you probably know that the blockchain is actually older than most people think. It's actually the invention of it is since 1991. It's a digital timestamp made by a bunch of researchers. They're trying to like verify digital records and stuff, but didn't really caught on till 2009 by the guy named Satoshi Nakamoto, who created after the financial crisis 2008. And then in Ethereum came out in 2015. But we'll go into a Bitcoin more in the third workshop, because I just want you guys to understand what the basic of this technology is. So yeah, this is just a brief overview of Bitcoin versus bank, transparency versus non-transparent, decentralized versus not, all this stuff. So we're going to start with hashing. So it's like the basics of blocks. So for hashing, what is a hash? It's a process of transforming any given key of a string of characters into another value. So think of it as a digital fingerprint for any data. And just remember that it's unique to every single string. So it's like, if you put high, the hash for that will always be the same for high, but it'll be different for other words. And I'll show you in the demo. So actually, I'll just show you the demo right now. So this is a hash. It's called SHA-256. It's created by a bunch of like US governments in the 90s. And it's a really popular hash. So this is the hash value. So it's all these digits. And it will always be unique. So you could put anything in. So let's say high. So this is the digit for high. And let's say I add another F. It'll be always different. But when you go back to high, it's still the same, 7AA4. And just keep that in mind. That's the basic of how blocks work. So that's like the basic core of how, like what keeps blockchain safe and secure and how it keeps it decentralized. So yeah, and then so this one, that's hash. Now we're going to blocks. So now we're building from the previous slide. So it's hashing, now we're going blocks. So each block is pretty much, what are blocks? Blocks are basic containers of information in the blockchain. So you could put anything in. You could put a picture of a dog, but mostly in Bitcoin, it's just transaction, just what the number of Bitcoin sent to this address is. So the basic blocks contain the following: the block number, the nonce, and the data. Nonce could be different for every blockchain, but nonce are normally either what do you have to make for mining, or it could be the what transaction number for your account is. So it really depends. So blocks append to the blockchain process and has an immutable property. We'll get into that, why it's immutable, and cannot be changed forever. So once that block has been verified, it's always forever on the blockchain. Then we're getting to blocks are secure with cryptography methods. So we're using hash to create public and private keys. So think of public keys as your bank account number. So let's say I want to send money to Paul. Paul has a bank account number, I can send to him. But private keys, think of it as like Paul's, it's like, think of it's my login info to my bank account, if that makes any sense. Or Paul's login info to his bank account. But public is like his bank account number. And then, yeah, so we'll get into blockchains. So actually, I'll go into blocks first. I'll show you what a block is. So block, think of this as a block. So this is like really, pretty much the watered down version of it. So this is a singular block. Let's say this is could be Bitcoin, but it could be anything. So this is block number 1. So let's say it's a Genesis block. And as you from the previous slides, remember the hash number. So then there's a mine button this time. So this is just like a demo, but it's different for Ethereum. Ethereum, you're trying to hash to some certain hash. So this nonce number is trying to, so this is the block number, this is data. So let's say everything's green right now, so this block is valid because there's 4 digits, 4 zeros in the front. That means the block has been verified. And that's how pretty much the basics of blockchain. So let's say I put data in it, it turns red because now it's not starting at 0. And this is where mining comes in. Like let's say you run a mining node on your computer, you're pretty much having a race condition, trying to figure out what number should I put in the nonce to make this 4 zeros. And that's pretty much what mining is pretty much. So let's say I press mine now. It'll take some time because it's pretty much counting 1 to this number to make this 4 zeros. Now this block is valid and it'll be added to the blockchain. That's how it works. So you can put any data, but mostly it's basic numbers in Bitcoin. And when it comes to Ethereum, it's just code. So yeah, that's pretty much what a block is. So let's just do it again. So let's say you could put anything. Hi, now it's not valid. That's how you could tell who manipulated with the block. Let's say first hi, then you have to mine again and see what nonce number. That's what it is. It takes some time, so it takes some computing power. So that's why nobody could really manipulate blocks. So yeah, that's what a block is. So now we're gonna get into blockchain. It's pretty much built on that. So it's just a bunch of blocks chained together. So yeah, this is blockchain. So this is pretty much the fundamentals of most cryptocurrencies. And they're pretty much just blocks consist of blocks, focus on blocks. So each block is interconnected by using the previous block's data, and hash computes its block hash. So think of, so now all the, let's start from this one. So this hash is all the data from this, this, and this. And it has 4 0, that means it's mine. So it means it's valid. So now to get this hash, it uses the previous hash and all the data. So let's say, let's say, so now this is just a bunch of chains. So all together, that's what a blockchain is. So let's say the last one, let's do the second last one actually. Let's say we manipulated it. See now how it turns red? Because this hash is not 4 zeros anymore. And this hash takes the previous hash, which changes this hash. So now you have to mine this one and this one. So that's why blocks. So let's go to the third one. So let's say you manipulate this one. So now you have to mine this one, which takes some time. And this one now has 4 0, which means it's valid. And this one, you have to mine this one. But then you're like, wait, can't someone just do that and just change pretty much anything in the history? Let's say Paul sent 4 Bitcoin to me, right? Let's say Paul sends 4 Bitcoin and you manipulate, you mine. Now it's all valid. So Paul actually sent 4 Bitcoin here. But then you go back, then change 5 Bitcoin and mine again. How do you stop that problem? So this now comes peer-to-peer networks. You probably heard of it in your classes, but so what a distributed network is, it's a peer-to-peer network. So how to deal with this, it's pretty much involves some game theory. So think of everybody is running the whole blockchain on the computer. So they all have the whole ledger, everything. And then it's kind of like a voting. It's kind of like a majority wins kind of thing. So you check the last block hash number and see what is a majority of that last hash number, and that wins. So technically it is hackable if you have enough computing power. But like, let's say there's pretty much 100,000 of nodes running around the world. So you need a lot of computing power. So it costs a lot of money if you really want to hack it. And that's why nobody has really hacked it yet, because it costs probably billions of dollars. So yeah, so now I'll show you how to stop that. So this is what a distributed blockchain is. This is what literally what Bitcoin is and most cryptocurrency. They're just a bunch of, let's say I'm peer A, I'm running my nodes in my computer. Peer B is Paul, and peer C is like Teddy. We're all running this node, and we're all checking the last hash, because that means it's verified, the 4 zeros on the last hash. Let's say let's do this. I manipulate it and say, let's create 1 Bitcoin, like just somehow manipulate it. And then you have to mine this, which is good now. And then you mine this. And then you're like, okay, well, technically I just modified something. This is all blank, but I modified it and everything's green. But now to stop that happening is you have to check the last hash. So now it's this hash pretty much is 006C1. This one is 000E4, and this one is 000E4. So majority wins. So therefore, you can't really modify stuff in the past because it takes time to mine this, and you need to majority win. So that means I think there's probably around over a few hundred thousands of nodes running. So that means you need to somehow run the majority, if that makes any sense, to modify that. So that's what a distributed blockchain is. And that's why it's literally pretty much unhackable, but is hackable if you have enough computing power. But yeah, that's pretty much what a peer-to-peer network is. And now we get into tokens, because like on it, obviously this is kind of useless data. Like I could write hi and like, what's the point of running this, right? Like there's literally useless data. Like who the heck's gonna run this? There's no like incentive or like monetary incentive to run this. So this is where Paul will explain you could actually create tokens and put into this and it actually has some value. So that's where now it's actually some useful, because blockchain was kind of useless because there's not any like value in the data, if that makes any sense. So now Paul will explain when you put tokens to this, it'll make more sense.
Sounds good. I am gonna share my screen now.
You can use my screen too if you want, Paul. Okay, you got it. Okay, sweet. Okay.
Does this look all right?
Yeah, that's good.
Okay. Yeah, so we're gonna get into tokens right now. So first, before we get into tokens, I want to give a brief explanation on just like what a ledger is, which like the term itself isn't necessarily like self-explanatory, but you can think of a ledger as a database. And more specifically, you can think of it as just like a logbook that contains a list of transactions. And it can be like a physical or an electronic one, as it says here. And given that there are multiple different kinds of ledgers, and together they do build what like a certain blockchain like Bitcoin or Ethereum is. So for instance, we have distributed ledger, a public ledger, and a decentralized ledger. So a public ledger really is just a record system that records are viewable publicly. However, it does keep the participants' identities secure and in an anonymous form. So that can be done using like a hash, or like your account address in the form of a hash. So you don't know specifically who the person is, but there is this anonymous kind of hash that will represent that. A distributed ledger is a database of records which are updated independently by each participant and node. And this information is just replicated and shared amongst many institutions like people, banks, whatnot. And a decentralized ledger is similar to distributed. However, it's one where a record of all of the transactions are kept on this decentralized network. So this network where these records are maintained and updated by many different independent nodes, not a centralized institution. So like computers, for instance, like a different computing power. So like Bitcoin and Ethereum are examples of distributed public decentralized ledgers. Yeah, just a little explanation for that. And now we're gonna get into token demo, which kind of builds off of what Perry was talking about with the distributed blockchain. So on this website, if we go to the tokens here, we can see that it's similar to how a distributed blockchain works with data, except now we're actually giving some substance to what the data is. So here we're actually going to be storing financial transactions in the form of data. So we're seeing here that $25, I mean, in this first block, $25 is being sent from Darcy to Bingley, and $4.27 is getting sent from Elizabeth to Jane. And everyone that's running this blockchain has a copy of it. So this is what that peer-to-peer network is. We have a peer A, which has a copy of this blockchain, and we have peer B, which has the exact same copy, and peer C that has the same copy. So we can do a demonstration, an example very similar to how it was with distributed blockchain. So let's say,
yeah, like change like the second last one, Paul.
Yeah. Let's say here, in like there's $62 getting sent from Rick to Ilsa. But let's say that somebody wants to go back and manipulate that data. So they want to go in and just send $400 from Rick to Ilsa. And as you can see that the blocks are invalidated, which means that you have to mine them to validate it. So we're going to do that. This one's taken a long time.
Also, time's a big thing because it takes time to mine, but blocks are always moving. So it takes, the farther back you go, the more computing power it takes.
Yeah, so finally that one got validated at a nonce of 90,000. And then we can do the same thing with the last one here, which got done a lot faster. But we can see that it's the same idea as before with the 51% problem, just that we can see that the last hash in this blockchain from peer A starts with 9BD3, and this one here is BAA0. This one here is BAA0. So we can tell just by looking at the last hash of the last block that something wrong happened in this blockchain. Something's been manipulated. So because of this majority rules, we can see that something's been wrong here, and we need to just like throw it out. That it's not going to be validated overall. So that's a simple way of how we can look at kind of a distributed blockchain amongst different peers using these tokens or this actual financial value. So we'll go back here, and we can do actually this next demonstration, which goes off of it. It's a Coinbase demo, and again, a simple link for it if you want to follow along is right here. But what each block does is all it does is it is sending money, in this case, sending money from one person to another. So here we're saying that $10 is being sent from Emily to Jackson, but how do we actually know that Emily has $10? There's no way that we can tell other than looking at the previous blockchain or at the previous block. So that's where this Coinbase example comes in. Is that we can actually just kind of create money out of thin air. And in this case, we're creating $100 and sending it to Anders. And in that way, when we're here on the next block, and now you can see that Anders is sending $10 to Sophia, 20 to Lucas, 15 to Emily, and 15 to Madison. We can see just by looking at the previous block that Anders has those funds to send. So really, this is just kind of a very high level overview of what a blockchain looks like. And we kind of want to just present it in a way to conceptualize it this way, because really like the inner workings of how different blockchains like Ethereum work is obviously a lot more complicated. But as a general high level explanation, this should be just a high level explanation. So yeah, I encourage everyone really to kind of like go onto this website and just mess around with the different hashes and like kind of see how the data is being manipulated and changed. So it's a very good demo to kind of familiarize yourself with. But yeah, I think that's kind of the end of this workshop. What do you think, Perry?
Yeah, pretty much. Yeah.
Yeah, so again, yeah, thanks everyone for coming to this. We don't really have much left to go over with this first one. This first one's just a very brief and vague introduction to what blockchain is, and we're going to be building off of this kind of knowledge given the next workshops that we're going to be working on. Second one actually being tomorrow.
Right.
So yeah, I think we'll stick around for a few minutes if anyone wants to ask any questions or if they have anything that didn't quite understand. But yeah, thanks everyone for coming.
Yeah, and also this next workshop is about proof of work versus proof of stake, setting up MetaMask, getting Ether from a faucet, and we'll show a visual demo of how Ethereum transaction even works.
Mm-hmm. Yeah, thanks guys.
Maybe you should stop the recording, maybe?
Yeah,
Or you think should we leave it on? You can leave it on, eh? No worries. Do I feel like a TA?
I know, right?
That's what a TA feels like.